Hello, welcome to lesson 4 of this week. We're going to be talking about a different compound that's a hydrocarbon, alkenes, today. But as always, let's do a little bit of revision and our retrieval first. So it's the same as what we did last lesson. So we're going to be looking at another reacting masses question. So you've got your balanced equation above, and I want you to, using the same method that we used last time, calculate the mass of carbon dioxide, so that's the CO2 on the end, made when 4.8 grams of carbon, so that's the green C, reacts. So if you pause the video and then we'll go through the answers. Wonderful. So filling it in, carbon is the known substance. We know there's 4.8 grams of it, so this is what's going to go in the first column. Carbon dioxide is the thing we don't know, and reminding ourselves that we can forget about everything else that is mentioned, that's not mentioned in the question, sorry. Even if it's in the equation, if it's not mentioned in the question, you just forget it. So we work down the left-hand side and up the right-hand side. So carbon has a mass of 4.8. We've got that from the question. The relative formula mass of carbon, or the relative atomic mass, because it's just an element, is 12. And then to get the moles, you do the mass divided by the relative atomic mass, which gives us 0.4. Now, the next bit is to look at our ratio. Now, we do that by looking at the numbers in front of the compounds in the equation. So we've got effectively a 1 in front of the carbon and a 3 in front of the CO2. So it's a 1 to 3 ratio. So for every 1 mole of carbon you've got, you would make 3 moles of carbon dioxide. But we've not got 1 mole, we've got 0.4. So we're going to times that by 3, and that gives us 1.2 moles of carbon dioxide. Now, the relative formula mass of carbon dioxide, by adding 1 carbon, 2 oxygens together, so 12, add 2 lots of 16, gives you 44. And then rearranging the equation for moles, you times those together. So if you've got 4.8 grams of carbon, you will make 52.8 grams of carbon dioxide. So make sure you've gone through your answers, use the table, it's the easiest method, and if there's anywhere that you've gone wrong, make sure you're writing the correct answer. Okay, lovely. So what we're doing today is we're looking at alkenes, and before we do, we're going to look and recap a little bit about alkanes so that we can make a direct comparison. And then, very similar to what we did in our first lesson when we learned about alkanes, we're going to look at the structure, look at the formula, look at how the number of carbon atoms and hydrogen atoms are linked. So either using your notes, but preferably not, I want you to think and I want you to draw the displayed formula. So that's where you can see all the bonds, and I want you to write the chemical formula for methane, ethane and butane. So remembering that the order goes in MEPB, so we've actually missed one out. I've not just named the first 3. So methane, ethane, then there's another one, then butane. So draw those out, showing all the bonds, and write the chemical formula as well. Remember that carbon will always make 4 bonds and hydrogen will always make only 1. Okay, lovely. So let's see how you did. So the first one being methane. Methane, you hopefully should know from that, most elephants prefer bananas, is the first alkane with just 1 carbon and looks like that. So to fill the 4 bonds with carbon and hydrogen, you get methane is CH4. Now the next one down is ethane, which then has 2 carbon atoms. And remember that you draw the carbon atoms first and put the bond between the carbon atoms first. And then to make sure that you've done it right, you fill up the carbon to make sure it's got 4 bonds in total, including that carbon bond in the middle. So then we get ethane, and that is C2H6. Now we missed out propane. The next one would be butane, which is 4 carbon atoms. So it looks like this, and it's C4H10. So as always, just as if we were in class, correct any incorrect answers. Make sure you can see where you've gone wrong. If you can't, feel free to send me an email and I'll go through it with you. So now we've done this, what I want us to look at are alkenes. So we can see that very similar alkanes and alkenes, and there's one distinct difference between them, but it actually makes a massive difference to the properties of the compound. So these are two examples of alkenes. Now they are very similar to alkanes in that they again the hydrocarbons. So they are only made up of carbon and hydrogen atoms. There's nothing else in there. We will start looking at other compounds where you've got oxygen, but alkenes are hydrocarbons. They do not have anything other than carbon and hydrogen atoms. The carbon atoms still make 4 bonds and the hydrogen atoms will only make 1 bond. That's the same for anything to do with carbon and hydrogen in chemistry. So that doesn't change between compounds. But the difference to alkanes, and you can probably see this, that they've got carbon-carbon double bond. So that bond in the middle that looks like an equal sign basically means that carbon, instead of just sharing one of its electrons with another carbon, it shares 2, so creates a double bond. So if you count that as 2 bonds, as you should, the carbon atom still has 4 bonds. If you look at each one in those diagrams, you can see that each carbon has 4 lines coming off it. So it's still got 4 bonds. And as a result of this carbon-carbon double bond, it means that less hydrogens can attach on. So you can see from the top one that you've only got 2 hydrogens per carbon atom, whereas if you had 2 carbon atoms in an alkane, each hydrogen, there would be 3 hydrogens on each carbon atom. At the bottom, you can see an alkene with 3 carbon atoms, and hopefully you'll notice that there's only 1 carbon-carbon double bond. Alkenes, the way we're going to learn about them, only have the carbon-carbon double bond once, and it's always on the end. Now that I'm going to show you an example in a bit. That can be on either end. It doesn't matter because you could flip it over and it would look the same. So that carbon-carbon double bond can be on either end on the last 2 carbon atoms. So you can have a long chain, and it could be between the first 2 carbon atoms or the last 2 carbon atoms, but it's always on the end. You may see pictures if you ever need to Google it or anything and you're looking for alkenes on the internet, you may see pictures where you've got the double bond in the middle, coming off in other directions, things like that. Ignore that for now. That does happen, but we don't need to concern ourselves with that. We are just learning about the alkenes, the simple ones, where the double bond is either between carbon number 1 and 2, or it's in the last ones. And they're exactly the same because they're just a mirror image of each other. Hopefully what you'll also notice is the hydrogen atoms on that carbon bond where you've got the double bond will come off at an angle. Now, right now you don't need to know why that occurs, but it is good practice to draw them on. And again, if you Google this, you might see that that's not always the case. It's not always the case, but this is the correct way of drawing it out, and we'll do some practice. So they're called unsaturated. Now, when something is saturated, it means it can take no more, whatever it is. If you're talking about something being very wet and it's saturated, it means it can't take any more water. And it's the same with this. So alkanes are saturated. That means they've got all the single bonds, they're really unreactive, and they can't take anything else. They're full. You can't put any more hydrogens in, all the bonds are made. Now, alkenes are known as unsaturated, and it's because of that double bond. Because if that double bond was to break, you can then add something else in there. Now, as a result, this means they react with other substances. Alkanes don't and alkenes do. And it's all because of that double bond between those carbon atoms, which we will learn more about in this topic. So, in the same way that we did last time, we're looking at a few examples and we'll look at the molymod diet pictures of what it would look like and how they take up space. Now, hopefully you've noticed I've not started with methane, which would be methane is the first alkane. Methane, the alkene, does not exist because you need a minimum of 2 carbon atoms to have that carbon-carbon double bond. So the first alkene is ethene, and we've already seen this displayed formula, so C2H4, because you can see that every carbon atom has 4 lines coming off it, meaning that it's got its 4 bonds. And you can see in the bottom right hand corner what that looks like in terms of the molymod and how it would take up space. So it's a much flatter structure, where the others had the tetrahedral shape. Because of the double bond, they don't have that anymore, but you can see how it does take up shape. Now if we look at propene, so that's the other one that we have looked at. So you've got your carbon-carbon bond between carbons number 1 and 2, and then propene, prop meaning 3, just like it does with propane. You've got your third carbon on the end, and then it's filled up with hydrogens, not forgetting the last one, where that, or the first one, where the double bond is, the hydrogens come off at an angle. Okay, so what I want you to do now is I want you to think and use this diagram. So I'll give you some time to go back. I want you to draw those 2 structures out for ethene and propene, and then I want you to do the same for butene and pentene, or the next one. So remember, they go down, they are the next 2. So we've already done 2 carbons and 3 carbon atoms. So the next 2 will be 3 and 4. And I want you to write the chemical formula as well. So pause the video and do that now. So let's see how you got on. So butene, there's 2 ways of drawing it. Both of these are correct. So like I said, that double bond can go on the first 2 carbon atoms or the last 2 carbon atoms. It doesn't matter. They are purely a mirror image. You can flip one over and it will fit onto the other one. So they are both correct, and it doesn't matter which one you use. Personally, I like to put it on the end. I always go with the first diagram. I always put it on the last 2 carbon atoms, and that's just because that's how I was always shown when I learned about these at school. Not forgetting, or my apologies, I've just realised there is a mistake on the PowerPoint. The first diagram is missing 2 hydrogen atoms on the second carbon. So do make sure that you've got all the hydrogen atoms on that second carbon. My apologies. So if we look at the diagram on the right, that is the correct one with the correct number of hydrogen atoms. The first one is missing 2 hydrogen atoms on carbon number 2. But otherwise, if you look at the carbon atoms, there's 4 carbon atoms in a row. Each carbon atom has got 4 bonds. So if you count the lines coming off it, you make sure it's got all 4, and the hydrogen atoms are on the double bond are coming off at an angle. So if we look at pentene now, hopefully these diagrams work. This is a lot more successful. So you've got 5 carbon atoms in a row. The double bond either between the last 2 or the first 2. So again, both of these are absolutely correct. And the hydrogens filling up, and we've got the correct amount of hydrogens on that. If we look at the chemical formula then, so butene here would be C4, and then you count the hydrogens, H8, and then you look at pentene, and that would be C5H10. So in the similar way, before you need a table, you're going to need another 5 rows underneath as well. And I want you to just draw and complete this table. So the structural formula, just give me the chemical formula. So how many C's, how many H's, not forgetting that those numbers need to be small and hanging below the line. So pause the video now. Okay, so let's very quickly go through those. So we've seen these diagrams for all of them. So ethene, there's 4 hydrogen atoms, so it's C2H4. And if you focus on the size of those numbers, it is really important, and those letters must be capitals because they are both elements with just one single letter. So propene would have 6 hydrogen atoms, so be C3H6. Butene would be 8 hydrogen atoms, C4H8, and pentene would be 10 hydrogen atoms, C5H10. 10. And I'm hoping that what we're going to move on to now, when we look at the link here, you're beginning to be able to deduce that for us. So that's the last thing I want us to think about now, is that link between the number of carbon atoms and the number of hydrogen atoms. So if you look now with the link between the number of carbon atoms, number of hydrogen atoms, the structural formula will help you, and hopefully you'll notice this time it's a little bit easier than it was for the number in alkanes. Okay, so this time you should notice that all you have to do is double it. So you double the number of carbon atoms to get the number of hydrogen atoms. So our general formula this time is CnH2n, where n can be absolutely any number. You could have millions, you could have hundreds, you could have thousands. It could be some completely random number. It really doesn't matter. But the link to work out the number of hydrogen atoms, you just very simply double that. So last thing I want us to do then today is for you to complete the rest of the table using that relationship. Now, hopefully you'll be able to work out the names. Think about those, the prefix of the shapes in maths. So we've got a pentagon, which has then created pentene, and it's the same as with the alkanes. If you need to go back and look at your notes for the alkanes, the names are exactly the same, just with "ene" on the end instead of "ane." So you're going to go all the way up to 10 carbon atoms, just writing in the number of carbon atoms, the number of hydrogen atoms, and then the structural formula. So pause the video now and complete that task. Okay, then, so the last thing we're going to do is just go through those answers and check that you've understood it well. And then next week's lessons, we're going to be applying this information and comparing alkenes and alkanes in a little bit more detail and looking at how we use them and the reactions that they undergo. So the next one would be hexene, which is 6 carbon atoms, 12 hydrogen atoms, C6H12. Then we've got heptene, 7 carbon atoms, 14 hydrogen atoms, C7H14. And then you've got octene, 8 carbon atoms, 16 hydrogen atoms, C8H16. Nonene is the next one with 9 carbon atoms and then 18 hydrogen atoms, giving C9H18. And lastly, decene, 10 carbon atoms, 20 hydrogen atoms, and the formula is C10H20. Now, what you can be asked is, you can be given a formula and it would have random numbers in, and then you've got to identify whether it is an alkene or an alkane. And that's now very simple to do because you can just look at the relationship between the number of carbon atoms and the number of hydrogen atoms. And if all you're doing is doubling it to get the hydrogens, then you know it's an alkene. If you've doubled it and add 2, then you know it's an alkane. And as you'll find out in the next few lessons, it makes a massive difference on how these compounds behave. Because like I said, alkenes are what we call unsaturated, which means they will react. Alkanes, because they're saturated, they're full of hydrogens, there's no double bonds, means they don't react, and all we can do with them is burn them, which is what we learned about last lesson. So that's it for today. Any questions, please drop me a line, and tomorrow you'll be putting this into practice, what you've learned this week. Thank you very much.